The mega dredger Vasco da Gama, the world's largest trailing hopper suction dredger, a vessel that can literally move mountains of sand, clay, and gravel. Because Singapore and most of the Southeast Asian countries are teeming with people and economic activity, land, especially land on the seacoast, is in great demand. Land for housing, for commercial activities, and land for airports like the monster created at Hong Kong. This massive project has been called the dredging contract of the century, requiring 237 million cubic meters of fill at a cost of $700 million US. Vasco da Gama is here in Southeast Asia to play a big role in a massive rearrangement of Malaysian geography. Just across the Johor Strait from the port of Singapore, at Palapas on the eastern shore of the Sungai River, a former mangrove swamp, an 800-hectare container port is taking shape. The area around the river mouth has a shallow bottom covered with clay, unsuitable as a building site.
The project, located in Malaysia and Johor, is actually in stiff competition with Singapore. The problem for Malaysia is that the location is in a mangrove area.
Palapas is a container terminal situated on the river here, just in the south of Johor, Malaysia. The deal is to extend this container terminal and at the same time dredging the access channel.
Getting to the nearest deposit of quality sand means a voyage of 144 kilometers to a sandbank 40 meters under the surface of the sea. The journey begins in the Sungai River, dredging up a hopper full of clay.
Take Singapore Strait, entering the South China Sea, and coming here, back again in the territorial water of Malaysia. We are dumping the mud. We are coming here, just on this bank. You can see the bank here.
Before the dredging begins, a topographic survey is conducted. The result is a full-color map, which shows the physical characteristics of the ocean bottom. In one or two passes over this sandbank, the ship will fill its hold with sand and then return to the job site. Sand deposits suitable for land reclamation are being sought further and further from shore. To make the trips profitable, the dredgers have to move faster and be much larger. Measuring 201 meters in length and 36 meters wide, Vasco da Gama can suck up and carry 33,000 cubic meters of deep ocean bottom. The ship's hopper can hold more than 1,500 dump truck loads each trip and transport it at speeds approaching 30 kilometers an hour.
The sand sources in Indonesia and Malaysia is starting to be depleted nearby Singapore. And that means that we need to go further and further away from Singapore. We are more competitive to bring in sand from a large distance compared to smaller ships.
Captain Bleu began his career sailing bulk carriers around the world. On this ship, he's more than a captain. He's also a construction boss, sailing the ship and supervising the dredging operations.
In the beginning, it was a big change, because you cannot compare merchant navy and the dredging business. We are involved in much more technical problems.
And all the while Vasco da Gama travels in a never-ending cycle of dredging clay, traveling, dumping, dredging sand, traveling back, pumping, 24 hours a day, 7 days a week, for the 40 weeks it will take to finish the job. When the first part of the cycle begins, it will be in the heavy clay of the river bottom, where one of the biggest dangers in dredging lies in wait. Vasco da Gama, the largest dredger of its type in the world, is dredging clay from the bottom of the Sungay River in Malaysia. 33,000 cubic meters of clay, which will be loaded in her hopper tank and transported 144 kilometers offshore. As the clay is scooped from the riverbed, it is mixed with water and sucked up through the dredging pipe to the hopper. Still in a liquid state, it will settle out in the hold, and the water will be pumped back into the sea, leaving a load of solid clay. Transporting these huge quantities of clay will soon lower the bottom of the riverbed, making it accessible to the largest container ships. This is land reclamation on a mammoth scale, something which could never have been imagined by the pioneers of modern dredging. Early dredging was usually maintenance work, keeping riverbeds and harbors free from silt. The machine of choice for 3 centuries was called the mud mill, an endless chain of planks or buckets driven by a wheel in which men or animals were walking. In a famous drawing from the 16th century by Leonardo da Vinci, a floating dredging machine is shown, but apart from this model, there is no evidence it was ever constructed. By the 18th century, the lowland countries of Holland and Belgium had taken the concept of dredging to its limits. Further progress would come from the technologies being developed to power the Industrial Revolution, the age of steam. By 1802, the first really successful steam dredger powered by a 12-horsepower engine was capable of shifting 90 tons of sand an hour. By the end of the century, steamboat dredgers like this one were moving 100 times that amount, or 1/10 of the work done by a modern-day dredger. By 1900, all the dredging concepts in use today, including bucket dredgers and suction dredging, had been developed. And the advent of the diesel engine made them more powerful and more effective. All over the world, dredgers drove spectacular projects. The building of the Suez and Panama Canals, the enclosure of the Zuiderzee in the 1920s, and the incredible Delta Plan which shut out the sea in the Netherlands. This, along with the Great Lakes Seaway and other big river infrastructure projects in North America, led to the unprecedented reclamation and island building projects in Southeast Asia, which continue to this day. Vasco da Gama is owned by the Belgian company Jan de Nul and was launched in June of 2000 at the German shipyard Thyssen Noordzeewerk. With a dead weight of 60,000 tons, this mega dredger has 40% more carrying capacity than any other ship of her type in the world. During the 12 months it took to build her, Vasco da Gama was also given the most electric power ever put aboard a dredger. 30,000 kilowatts to power her monster pumps that can function at depths of 136 meters. The ship was christened for the famed Portuguese explorer Vasco da Gama, who was the first person to sail from Europe to India by way of the Cape of Good Hope. This voyage opened an all-water trade route between Europe and Asia. Now the ship that bears the name of this explorer of new lands is busy helping to create new land in the Far East.
Vasco da Gama started operating in 2000. That was exactly when the big reclamation contracts were signed here in Singapore. Really huge contracts. The amount of sand required was enormous. We went from maintenance dredging jobs to reclamation jobs. I could say that for our companies, percentage-wise, maybe 50 to 60% nowadays is land reclamation, whereby in the past that was certainly maybe only 10–20% land reclamation.
Maintenance dredging usually takes place in ports or shipping channels where silting is a problem and the bottom becomes too shallow to allow the deeper commercial vessels near the docks. A good example of this is the Port of New York. On the other hand, land reclamation involves the addition of sand or clay or stones to create more land in place of the water. On a job like the container port of Palapas, Vasco da Gama is performing both functions on each of her many voyages, lowering the depth of the Sungay River as she leaves and adding land to the new container port on her return. On board the world's largest trailing hopper suction dredger, everything is gargantuan. The hopper, the pumps, the pipes, and the mighty suction heads.
Here we are facing a so-called active drag head. It has a width of 8 meters and a weight of over the 55 tons. It mainly comprises a fixed part, which is connected to the suction pipe, and a movable part, which is hydraulically operated. The suction operation is supported by means of a nozzle system supplied by the high pressure jet pumps, and on the visor we have arranged a complete row of chisels to enable loosening of the soil.
Everything is all bigger. Some people were afraid of that the vessel would be too big to enable sufficient flexibility and operation, which was not the case.
The business end of this incredible vessel is the 2 suction or drag heads. Each of them weigh 55 tons. They hang off the end of 35 meters of piping. Like giant vacuum cleaner heads, they scrape the river bottom, and with the aid of water jets and a truly fearsome sucking action provided by the world's largest submerged dredge pumps, can transport the clay water mix up to the gigantic storage hopper.
The hopper hold has a length of 19 meters, a width of 28 meters. Further we see here the typical cross-section of the hopper, where we have the main deck, the ship's bottom, the inclined hopper bottom and the inclined hopper top. This is the net volume over a total of 33,000 cubic meters.
With both drag heads in operation, the hopper will be filled in about an hour. When she wants to discharge cargo, the ship will use one of 3 methods: pumping ashore a distance of up to 10 kilometers through a floating pipe, which takes about an hour. When the sand and water mix comes ashore, the water will run off the surface, which is very densely packed and strong enough to support a huge bulldozer. Although accidents are rare, a dozer slipping over the edge would itself become part of the brand new pier. Discharging through doors on the bottom is the fastest method and takes 15 minutes. Or rainbowing, a spectacular process which sends a spray out of a distance of 100 meters, emptying the 33,000 cubic meter hopper in just over an hour. On a recent pass over this very spot, fighting severe currents and dense clay, the portside draghead became completely submerged in mud. With the ship moving steadily forward and the starboard draghead still working and only instruments to tell him what was going on 10 meters underwater, the operator made an immediate correction. With the huge lifting power of his crane, he attempted to pull the suction head out of the mud. But the weight of the clay on top of the suction head was too great. The system ripped apart at the pipe connection, and only the safety chains kept this expensive machinery from sinking out of sight. Dredging continued using the remaining draghead, and within 12 hours the crew had repaired the damage. A good thing too, because on this ship the sands of time run fast, and time is money. Lots of money.
From the moment that we lost the draghead, from that moment on, 18 hours after that, we were back in operation with 2 dragheads.
Nevertheless, it's a problem that the captain doesn't want to see repeated as Vasco da Gama heads out into the South China Sea, the place where typhoons are born. In the South China Sea, the supership Vasco da Gama, carrying 90,000 tons of clay, is making her way to a dumping site 144 kilometers offshore. She will arrive at the site around 4:40 a.m. Once there, she will begin a process of unloading and loading that makes her a modern technological marvel.
The starboard main engine?
Yes, okay.
Because it's main engine failure.
The muscle to push this mountain of clay around comes from a diesel-fired power plant that generates more than 37,000 kilowatts. This huge power capability is necessary to power the 2 main engine propellers, dredge pumps, jet water pumps, bow thrusters, and stern thrusters. On this ship, all this machinery may have to operate at the same time.
I can only supply kilowatts, and that's done by 2 huge main engines, 14.7 megawatt, and 2 auxiliaries, 3,400 kilowatts.
To push the ship and its enormous cargo at a speed approaching 30 kilometers an hour, a gearbox takes power directly from the 14-cylinder diesel engines and links it to a pair of variable pitch LIPS propellers, which are located in protective nozzles attached to the ship. Cast from a mixture of aluminum, copper, and nickel, these lightweight props spin at 115 RPM. The variable pitch design means the angle of the propellers can be changed to slow down and reverse the ship.
And we can also have the two stern thrusters to maneuver the ship by dynamic position.
There are also two bow thrusters on board the Vasco da Gama, and all the thrusters can be coordinated by a computer-controlled satellite navigation system, which helps to keep the ship on a controlled track at a controlled speed automatically.
We have also built it as an unmanned engine room. That means we are able to run the ship with less engineers, more automatization. We can control it from the wheelhouse completely. Of course, we have a complete overview of the technical system on board of the ship.
All this power consumes a large amount of fuel, about 120 cubic meters of fuel every day. That's 120,000 liters, or enough to keep the average family diesel sedan going for 15 years. And refueling the ship has to be done at the job site, in between sailing and dredging. For the Vasco da Gama, that's about once every 3 weeks, a process that can take anywhere between 9 and 14 hours, depending on timing and manpower. On arrival at the dumping site, powerful water jets are sprayed inside the hopper, causing the cargo of heavy clay to flow towards the openings.
So once we want to flush this hopper from 33,000 cubic meters, it's done quite quick because we have two of these dredge pumps. So we have 9 cubic meters per second for each pump.
In real time, this is how long it would take these pumps to drain the average suburban swimming pool.
"18 cubic meter swimming pool, it's about two seconds, it's done.
With the clay removed from the hopper, a course is set for a 1-hour sail to the sandbank, where Vasco da Gama will make an enormous withdrawal. It's 5:10 a.m., and 2 decks below in the galley, the cook and his staff are getting ready for the crew members coming off their shift. The crew live and relax far away from the engine and pump rooms so they can enjoy some peace and quiet, even when the ship is working at full force. There's accommodation on board for 40 people, most of them in single cabins. When the Vasco da Gama arrives over the high-quality sand deposit and begins to scoop up the load for the container port on the Malaysian coast, she will be following one of the most amazing road maps ever seen. A full-color sonar map of the sea bottom presented on a computer screen. 144 kilometers off the coast of Malaysia in the South China Sea, the gigantic dredger Vasco da Gama is treasure hunting. In this case, the treasure is sand. Sand to create waterfront land worth millions of dollars to the rapidly expanding Far Eastern economy. 30 meters below her keel, construction quality sand that's getting harder and harder to locate closer to shore. But this doesn't pose a problem for the enormous drag heads, which can reach down 40 meters on their suction pipes to mine the ocean's floor. At the heart of the deep dredging operation are twin submerged dredge pumps, one on each side of the ship. Located in the suction pipes, they are based on a design developed by Georgia Iron Works in the United States and Krupp-Forder Technik of Germany. These watertight pumps are directly driven by the ship's main engines, which means a huge amount of power is available. Using this immense power in the best way possible is the job of the draghead operator. He has to ensure that the material needed to be removed is actually sucked up from the bottom. To make sure this is the case, the Vasco da Gama employs some very sophisticated surveying and positioning technologies.
The big difference between land mining and mining at sea is that with land mining you have a clear view of what you're doing. When you're at the quarry or something, you see everything is lowering. Here you cannot see under the water, under the sea level. But now with the modern technologies you can. With sonar surveys are done and you get a very good picture of what's happening downstairs.
The old Echo sounder with its blurred images has been replaced by multi-beam sonar with full-color displays, which provide 3D images of the worksite and show the ship's position in real time.
You see here the sandbank clearly shown on the screen. You also see the track of the vessel. You see here the white lines, that's the history of the track of the last 1.5 hours. You see here also the vessel. The vessel is turning for the moment. We just finished loading and we are now turning to return to the sand discharge area. The pipe operator sees perfectly the location of the drag heads and the dredge pipes in relation to the dredge ship. So if his pipe is going under the vessel, and he can take immediate action.
The tie is coming like this, so it pushes always the starboard pipe underneath the ship. So I always have to correct it by lifting it up a little bit and putting it next to the ship again.
The sand rocketing up the pipe is heavy and packed tight by centuries of settling. But nozzles on the draghead blast powerful jets of water at the seabed. The claws on the draghead rake up the sand, and the pumps suck the soupy mixture up the dredger pipe and into the hopper. It's important to get the mix of sand and water just right, since it determines both the speed and efficiency of the loading process. The operator has to create this mix using water volume and pressure.
The speed of the water going through the pipes, I can see it here.
John is reading data on 4 main fronts: how fast the vessel is traveling over the sand and in what direction, keeping the ship at the edge of the sandbank. At the same time, he has to make sure that river currents or tides don't force the suction heads under the hull, where they could smash into a spinning propeller. He also has control over which of the 8 hoppers he is directing the sand into. Loading too much at one time into the front of the ship could bring the stern and the propellers out of the water. What's worse, with so much weight coming aboard so quickly, the ship could easily be capsized. When a section of the hopper has been filled, the sand settles to the bottom and the water is drained off, making room for more of the sand-water mix. This will continue until the hopper is filled to overflowing.
Even now I have to look how I'm going to load. So we are lying like this, so I have to make the ship straight before entering for discharging.
Across the control room from the pipe operator sits the first mate.
I'm steering the vessel by low speed 1.5, 2 knots we made now over the ground. Here you see then here's the bank with the sand, but now I have some problems with the current. The current pushes the vessel to the bank, so I try to keep a straight course so the pipes are not going under the ship.
Ja, is goed. When he turns the ship on a certain position, the pipes go also away, so I have to pull them back and put them next to the ship again. That's why he's telling me I'm going port or starboard side.
This sand dance among the currents and shallows lasts for just over an hour. As the Vasco da Gama sets course for the Sungay River, the pipes and drag heads are brought up, cleaned, and secured on deck. For the next 5 hours, the crew will focus on equipment maintenance.
Yes, in our operation, really we need flexible people willing to do a multiple of tasks. We have different stages in our operations. There is the dredging part, there is the sailing part, there is the discharging part. That means that everybody needs to be able to fit in the three main activities. So let's say a dredge master, after having dredged a load of sand, will probably during sailing be working on the maintenance of the vessel, doing reparations on deck. And then when the vessel arrives in port or at the reclamation area and starts discharging, will run back to his desk to discharge the load to sand. So you really need people who are willing to be flexible and do all sorts of jobs on board of the vessel.
And when we are not dredging or discharging, we have to see for the maintenance of the pipes, the suction pipes, the pumps, the dredge pumps, see is everything not broken. If it's broken, we have to fix it.
Moving a very abrasive substance like sand at very high speeds will grind the thickest of pipes paper thin in just a few weeks. Daily inspections and a computer program that tracks past performance allows the crew to predict with pretty fair accuracy when to replace parts, replacing them before they fail. On this ship, just like on any construction site, time is money. That's why there's a stockpile of $12 million worth of spare parts on board. Propellers, pipes, pistons and pumps, and that's just stuff filed under P. With careful planning, skilled operators, and constant maintenance, the Vasco da Gama can stay operational for months on end, repeating the patterns of dredge, travel, dump, move and dredge, travel and pump, over and over, each time moving enough material to create a kilometer-long stretch of beach. But what is the long-term effect of this kind of activity? Is the price of one new environment the destruction of another? Laden down to her gunnels, with enough sand to keep Canada's highways ice-free from coast to coast, the Vasco da Gama is inbound from an offshore sandbank to a very anxious customer in Johor, Malaysia. She's part of a huge undertaking to create a new container port out of a former mangrove swamp. And it's activities like this, along with other dredging projects, that have created environmental concerns worldwide. Most of these concerns focus on the quality of dredged material, contaminated sediments produced by industry, agriculture, and human sewage. And the latest dredgers are being equipped to clear, relocate, and in some cases treat most forms of contamination. But there are also concerns about the damage done when clean materials like sand are dredged. This action of loosening, lifting, and transporting sand can create a phenomenon known as turbidity. solids which remain suspended in the water, reducing the amount of light and settling on top of marine life. On the Vasco da Gama, turbidity is reduced by slowing down the speed of the water, which is returned to the ocean after the sand settles out in the hopper. This is done with a system of pipes with valves inside them that work like siphons.
By reducing the speed of the water, of the backflowing water into the seabed, the flow in the water is much more calm. It's not disturbing the surrounding, and that's all what is required, is that we don't disturb the environment.
To build the Sungay River container port, the sand has to be firm sand. Big sand granules, not fine sand. This sand has to stay put and not flow away on the current when it's discharged. Using sand as a foundation for land building has an interesting history and has been used all over the globe, but perhaps never so famously as Miami Beach. It's been called the billion-dollar sandbar. 25 kilometers of sand facing the Atlantic Ocean at Biscayne Bay. Early in the 20th century, a group of American tycoons decided to create a brand new playground for the rich and frivolous. They dredged Biscayne Bay and created a man-made beach at an offshore mangrove swamp. The principal in all this was a man called Carl Fisher, who realized that the newly located sand was stable enough to support a real estate sign. Carl would row prospective buyers to a spot in the bay and then offer to dredge them up an island for their new home. When the islands got closer and closer together, they became a community. To the amazement of all of America, the sand was firm enough to support not only elegant homes, but hotels as well. Delightful Art Deco hotels strung out along the waterfront and painted in pastel shades of coral pink, ocean turquoise, and sunshine yellow. The rest, as they say, is history. And according to American humorist Will Rogers, Florida's national symbol should be the dredger. Arriving at Johor around midday, the Vasco da Gama won't be dropping the sand through her hopper doors or spraying it in a giant 100-meter-long arc from her bow. Instead, with the aid of a tugboat, she will hook up to a floating pipeline which stretches out nearly half a kilometer from the construction site. When the pumps start up, adding water to the sand to carry it through the pipe, it will take the ship less than 2 hours to empty the contents of her hopper on the shore, where waiting bulldozers will push it into place. The many towers sticking up through the sand are breathing and drying holes, which allow any moisture in the sand to evaporate. When the construction is completed, these pipes will be capped, but they will remain in place, breathing to keep the sand firm until there's no longer a need for container ports. But in this century at least, shipping goods by container is the most efficient and economical method of doing business on a global scale. And building more and more megaports will call for bigger and bigger dredgers. Without the relentless and repetitive performance of the dredger, very few of today's seaports would exist. And certainly no new ports like the one in Pelepas, Malaysia, would ever have been considered. Day after day, week after week, and in some cases year after year, new land is delivered to the builders of homes, industries, and shipping piers all over the world. After making a deposit of 90,000 tons of sand, the mega dredger Vasco da Gama will lower her enormous drag heads and begin the job of scooping up clay from the bed of the Sungay River. This ship, mightiest of its kind in the world, will soon complete its role in helping to build this 800-hectare container port in Malaysia. She is then scheduled for a refit, which will increase her carrying capacity by an additional 10,000 cubic meters, and also allow her to dredge a maximum depth of 160 meters below the ocean surface.
We do see a lot of projects coming up in the future in the offshore market.
An assignment on the east coast of Canada, dredging deep pits for oil and gas wellheads to keep them below the range of bottom-scouring icebergs. Vasco da Gama will also be able to work more efficiently on any of the 20 mega projects that the Jan de Nul company is involved in worldwide.
Future will bring most probably bigger vessels, sailing over longer distance, deeper dredging. When we designed Vasco da Gama, the biggest vessel was 22,000 cubic meters approximate. And we went up to 33, so that was for us an upgrading of 50% with respect to the market. So it is more or less a race, one vessel after the other, to upgrade capacities.
We have to go farther and farther to bring the sand. And if you are the one who can bring the biggest quantity of sand on big distances, you are the man who is winning.
From Singapore to Argentina, from Canada to Korea, wherever there is land to be created or transported, the supership Vasco da Gama will be ready to suck it up and get the job done.
Oh, I'm very proud of it because it's a very good vessel. It's strong. You feel it. It's a strong ship. It's a winner.